Welcome to The Explainer. Today, we're going to build a little revision guide for a huge concept in statistics, estimation. We're going to break down how we can make really smart, educated guesses about massive groups, like, say, an entire country, using just a tiny slice of data.
So, to kick things off, let's start with a question that sounds pretty much impossible, right? Imagine someone asks you to find the average height of every student in India. I mean, we're talking about hundreds of millions of people. Where would you even begin?
Well, the simple answer is you don't. You wouldn't even try to measure every single person. It's just not practical. Instead, you'd use a super powerful shortcut that statisticians have perfected. You'd estimate.
Okay, so here's our game plan. We'll start with why we even need this, that impossible question. Then we'll get into the how, the educated guess. We're going to look at two main ways to do it, aiming for one single precise answer versus creating a range you can really trust. Then we'll see where this pops up in your world and wrap it up by figuring out the big choice. Do you want precision or do you want confidence? All right, first up, let's really get our heads around why trying to measure an entire group, what we call a population in statistics, is almost always a non-starter.
I mean, the logic here is pretty easy to follow. Trying to collect data from everyone, whether it's every student in India or every single customer your favorite coffee shop has ever had, would just be a massive drain. It would take way too much time, cost an absolute fortune, and the effort involved would be just huge. Estimation is our way around all of that.
So if we can't ask everyone, how in the world do we get an answer we can rely on? Well, this is where the magic really starts to happen. Let's talk about estimation theory.
At its heart, estimation theory is just a formal way of doing something pretty intuitive. It's the process of taking a small, manageable piece of the puzzle. We call that a sample, and using what we learn from that little piece to understand the entire picture, the whole population.
And this breaks down that process beautifully into 4 simple steps. You start with the whole group, you pick a small, random sample from it, you analyze that sample, and then you use what you found to make an educated guess about the whole group. It's such a powerful idea, isn't it? We study the few to understand the many.
Okay, now that we've got the basic idea, let's dive into our first method for making that guess. It's called point estimation, and this one is all about finding one single laser-focused number as your best guess.
Think of it like this. You ask your friend how they think they did on a big exam. If they come back and say, "I'm going to get exactly 75, well, they've just given you a point estimate. It's one specific, very confident prediction.
And that's precisely what point estimation is. We take a value we calculated from our sample, like the average, and we use that single number as our best guess for the average of the whole population. You can think of it as our bullseye guess. We're aiming for one specific spot.
Here is a perfect real-world example. A bank wants to know the average loan amount across all of its thousands of clients. Now, instead of looking at every single account, they just pull a random sample of, say, 50 clients. They find the average loan for that group is 20 lakh rupees. So, that single number, 20 lakh, becomes their point estimate for all their clients.
But let's be honest, trying to guess an exact number is risky, right? If the real answer is just a little bit off, you're technically wrong. And that's where our second method, interval estimation, comes in to give us a much-needed safety net. Let's go back to our friend and that exam score. Now, listen to how the language changes. This time, they don't give one number. They say, I'm 95% confident my score will be between 70 and 80. They've given us a range, and just as importantly, they've told us how certain they are. That's a totally different kind of guess.
And that is interval estimation. Instead of a single point, we give a whole range of values, and we state how confident we are that the true answer is hiding somewhere in that range. Sure, it's less precise than a single number, but it's way more likely to be correct. So whenever you see an interval estimate, it's really made of a few key parts. You've got the range itself, which has a lower limit and an upper limit, and then you have that confidence level, the percentage that tells you just how probable it is that you've managed to capture the true value inside your range. Now, this might all sound a bit like a boring stats lecture, but I promise you, you bump into both of these types of estimation all day, every day, and you probably don't even notice. Think about it. When a retail store predicts that the average shopper spends between 850 and 950 rupees, that's an interval. When your bank says it'll take 5 to 7 days to process your loan, or your navigation app says your trip will take 25 to 30 minutes, yep, those are intervals too. But when the manager at a supermarket says the average queue length is 4 people, that's a point estimate. See? It's literally everywhere.
Okay, so we have these two fantastic tools in our statistical toolbox. One is super precise, but kind of risky, and the other is more reliable, but a bit broad. So how do you know which one to use? Well, it all comes down to a classic trade-off. You really have to decide what's more important for what you're doing. Do you need that bullseye precision of one single number, even if you know there's a good chance you might be slightly wrong? Or do you prefer the safety net of a range, which gives you confidence that you've probably caught the right answer, even if it's not quite as specific? And that's our quick tour of estimation. You know, the biggest thing to take away from this is that understanding the difference between a precise point and a confident range, it's not just for statisticians. It's a way of thinking that helps you better understand and question all the numbers and predictions you see around you every single day.